Alright, Assalamu alaikum and hello everyone. So for this session, we're going to look at Gauss elimination with partial pivoting. So in the previous session, we have looked on Gauss elimination. Now we're going to look Gauss elimination with partial pivoting. So what does it mean by partial pivoting? So basically for Gauss elimination, in every step, we must make sure that the matrix must be checked and rearranged if necessary, such that the diagonal element is not zero. So in the previous session, so basically all our diagonal matrix have values. Sometimes in a matrix, the diagonal element contain zero value or almost zero. So basically, for this method, Gauss elimination with partial pivoting, we're going to rearrange the matrix so that the largest absolute and non-zero diagonal element is not in the diagonal element. For example, right, let's look on example 3.2 here. So we've got system of linear equation, and then if we change it into augmented matrix form, it becomes like this. So if you can see here, okay, the diagonal element contain the value of almost zero here. Okay, so basically we need to swap. Okay, we need to swap the row here, row number 1 with row number 2, so that the diagonal element from here will change to this row. So if you can see now, because we have swapped R1 and R2, so our R1 has become 500, -1 and 3 and 6, and row number 2 now has changed. So basically we have swapped row number 1 with row number 2. So that's why now in our diagonal element does not contain almost zero value. So initially from here, okay, everything in here, we swap it with row number 2. So row number 2 become row number 1, row number 1 become row number 2. So end up we got something like this. Okay, and then next step is that, so now all of our diagonal element does not contain zero. So next we need to eliminate anything below the diagonal to become zero. So because this is a bit messy, okay, now it has been transferred to this. So anything below the diagonal element needs to become zero. So we need to do row by row. Okay, do this one first, make sure everything on row 2 becoming zero, and then we're going to eliminate number 4 here on row 3 to become 0, and then any value here to become 0. So if you can see from this example, okay, from 0.02 it has become 0. Okay, then next we're going to eliminate the value 4 here to become 0. So by using the multiplication factor, this has become 0. Okay, and then next is change this one to become 0, and then end up we can use backward substitution. Okay, if you can see here, basically from here you can see that the diagonal element is 0.976. So for this example, it asks to swap row 2 with row 3. But from my point of view, since the value here is almost equals to 1, so to me we don't need to swap unless if the value of 0. maybe 4, 3. So if we round off, we'll get 0.4. So 0.4 can be considered is almost to 0, then we swap. If the value is close to 1 here, so we don't need to swap. So basically, if you try to solve this one, and if you don't swap, you can still get the same answer. Okay. All right, let's look at some example that is a bit easier to understand. So this is a Gauss iteration with partial pivoting. Okay, remember that when your diagonal element contains value that is almost 0, so we need to swap. Okay, so if I have a system of a linear equation of 0.02x1 plus 300 x2 plus 10x3 equals to 9, 500 x1 minus x2 plus 3x3 equals to 6, 4x1 plus 7x2 plus x3 is equals to 2. So we write it in complete matrix form. So 0.02, 300, 10, x1, x2, and x3 equals to 9, 6, 2, and then 500 x1 minus 1x2 plus 3x3 equals to 6, and 4x1, 7x2, 1x3 equals to 2. So next we write it in augmented matrix form. So it becomes 0.02, 300, 10, 9, 6, 2, 500, negative 1, 3, 4, 7, 1. Okay, so this is in augmented matrix form. So next, okay, let's look at the diagonal element first. Okay, if you realize here, one of our diagonal element, which is located on row number 1, contains a value which is almost 0. Okay, this value is close to 0. So with partial pivoting, what we're going to do is we're going to swap row number 2 with row number 1. So row number 1 will become row number 2, and row number 2 will become row number 1. Okay, so we swap R1 and R2. Why we're going to swap? So that the value here will move to here. So when we swap everything, when we swap the whole row, so this one will go here, this one will go here, and then this value will go on the first row, this value will go on the first row, same goes to this one. Okay, so now once we swap the value there, okay, it will become 500, negative 1, 3, 6, and then 0.02, 300, 10, 9, 4, 7, 1, 2. So this is our first row, this is our second row, and this is our third row. So once we have ensured that our diagonal element does not contain 0, so we're going to proceed with the normal Gauss iteration method. So basically we'll do row by row. We're going to eliminate this one first, and then once the value here has become 0, we're going to eliminate this one, and then next we're going to eliminate this one. So let's do one by one. First we're going to eliminate 0.02 from R2. So eliminate A1, eliminate A21 from R2. So find the multiplication factor. M21 is equals to A21 divided by its diagonal element, which is the value of 500 here. So A21 is 0.02 and A11 is 500. So 0.02 divided by 500 is 4 times 10 to the power of minus 5. So negative M21 is equals to negative 4 times 10 to the power of minus 5. And the equation that we're going to use, M21 row 1 will multiply with row 1 plus row number 2. We're going to transfer everything to row number 2. So if I write it, M21 row 1, okay, so 500 times the negative multiplication factor, we get 0.02, and then negative 4 exponent negative 5 multiplied by 1. So basically we're going to multiply the multiplication factor with all the value from row number 1, yeah. So this one will become negative 4 times 10 to the power of minus 5, and then multiplied by 3, we get 1.2 times 10 to the power of minus 4, and then multiply by 6 here, 4 6, we get negative 2.4 times 10 to the power of minus 4. Okay, so negative M2 R1 plus all the values from row 2. Okay, so we're going to use this value plus all the value from row number 2. So this one will become 0.02, sorry, this is negative here. Okay, this one will become 0. So negative 4 exponent negative 5 plus 300. So this one will become 299.99996. Then 1.2 exponent negative 4 plus 10. So 10.00012, and then negative 2.4 exponent minus 4 plus 9, we'll get 8.99976. So basically this is the value that we're going to transfer to row number 2. So now our matrix will become 500, 1, 3, 6, and then I write row number 3 first because nothing has changed on row number 3. 712. So what has changed is row number 2. So the value of row number 2, we'll get it from here. So this is 0299.9996. This one is 10.00012, and the value here has transformed to 8.99976. So now this is our R1, R2, and row number 3. So if I draw the diagonal line again, so next what we're going to do is we're going to eliminate the value 4 here from row number 3. So 3 is eliminate E31 from row number 3. So find the multiplication factor first. So M31 is equals to E31 divided by its diagonal element. Okay, divide by 500. Oops, sorry. Divide by A11. So 4 divided by 500, we get 8 times 10 to the power of minus 3. So negative M31 is equals to negative 8 times 10 to the power of minus 3. So the equation that we're going to use is negative M31 multiplied by row 1 plus row 3. We'll change to row number 3. Okay, so the same, just proceed with Gauss iteration. So negative M31 row 1. Okay, so we're going to multiply the multiplication factor on the value of row number 1. So negative 100. So this one will become negative 4. So the second one will become 8 times 10 to the power of minus 3. And then negative 8 exponent negative 3 times 3. Negative 0.024, and then negative 8 exponent negative 3 times 6, 0.048. So that is M31 multiplied by row number 1. So next, negative M31 row 1 plus row 3. So basically we will add all the values here with row number 3, and then we're going to transfer all the values on row number 3. So negative 4 plus 4 is 0, and then 8 exponent negative 3 plus 7 is equals to 7.008, negative 0.024. This one is 0.976, negative 0.048 plus 2, 1.952. So basically this is the value that we will replace in row number 3. So now our metric, what will change is the value on row number 3. So this one is going to be the same. The first row 1, 3, 6. On the second row remain the same, 299.9996. Then this one is 10.0012. I don't have enough space, so I'll write it again. So 3, 10.00012, 6, 8.99976, and then the last one, 4. So the last row, for the third row, we're going to obtain the value from here. So 0, 7.008, 0.976, 1.952. So now this is our row 1, row 2, and row 3. So if I draw the diagonal line again, so next what we're going to do is that we're going to eliminate this value here from row number 3, because we do row by row and then we move to column. Okay, so this one has already become 0, this one has already become 0. Now we need to eliminate this one. So step number 4, eliminate A32 from row number 3. So the same approach. Okay, find its multiplication factor first. M32 is equals to A32 divided by its diagonal. So the diagonal element is this one, which is A22. So 7.008 divided by 299.9996 is equals to 0.02336. So negative M32 is negative 0.02336. So negative M32 multiplied by R2 plus R3. Going to transfer it R3. So negative M32 R2. Okay. So we're going to multiply the multiplication factor on all the values of row number 2. So this one 0. So 299.996. This one will become negative 7.008. So third one, negative 1.02336 multiplied by 10.00012. Negative 0.2336. And the last one, negative 0.02336 multiplied by 8.99976. We get negative 0.21023. Okay, so negative M32 R2 plus R3. So basically we're going to add all the value here with all the values from row number 3. Okay, so this one will become 0. Negative 7.008 plus 7.008 becomes 0. Negative 0.2336 plus 0.976 goes to 0.7424. And then negative 0.21023 plus 1.952, we get 1.74177. So this is the value that we're going to transfer to row number 3. So our matrix will become 500, -1, 3, 6. Okay, and then row number 2 will remain 0, 299.9996, then 10.00012, 8.99976. Okay, so what will change is the value on row number 3, in which we will obtain from here. Okay, so it becomes 0, 0, 0.7424 and 1.74177. So if you look here, okay, anything below our diagonal line is 0 already, so we can use our backward substitution. Okay, so starting from row 3 first. So from here we know that 0.7424 x3 is equals to 1.74177. So x3 is 2.3461. Okay, now since we already obtained x3, we move to the second row. So from the second row, 299.9996 x2 plus 10.00012 x3 is equals to 8.99976. So 299.9996 x2 plus 10.00012, we already obtained x3, which is 2.3461 is equals to 8.99976. So our x2 will become 2.3461 times 2, 8.99976. X2 is negative 0.0482. Okay, so now from row 2 we move to row number 1. We do backward substitution. So from the equation, 500 x1 minus x2 plus 3x3 is equals to 6. So 500 x1 minus negative 0.0482 plus 3 x3 is 2.3461 is equals to 6. So x1 is negative 2.173 times 10 to the power of minus 3. So from the backward substitution, we have already obtained the value of x3, x2 and x1. So that's all for today.